Lesson 21, page 101, 102, and 103. Two sections to this. First section has to do with scientific notation. Second section has to do with two statements of equality. Scientific notation. How many times have you learned scientific notation? Way too many.
Once.
Do you have it down?
Mr. You already told us that you listen. I didn't hear you. God. Is it late? Should not be late.
All right, so lesson 21. Start out with scientific notation. If I have a number such as 0.0003, as far as writing something in scientific notation, I need somebody to give me some rules. Rule number 1. No jumping on the bed, yes.
Get rid of all your zeros.
Okay, so Kendra says get rid of all my zeros, and I have 3 then for an answer, and I'm done.
No.
Yeah.
Okay, so there must be something else besides getting through all the zeros. It would be easier, it would be nice.
You move to the right, it's times, and
Move
left
the
is
decimal
divide.
all the way to the other
You move the decimal
other end.
left or right, depending on what you're given. Depending on what, Tommy?
What side or what where you're going with.
Okay, so you're looking for one of your numbers that's not 0. And one digit needs to always be to the left of the decimal. Doesn't matter what the digit is, but it has to be a natural number. Natural numbers from 1 to infinity cannot be 0. That one digit has to be to the left of your decimal. So we're going to move it until it's there. So now my 3 is on the left-hand side of the decimal. You don't need the point 0, but I put it up there just to show it was there. Second step is you put a times 10, which isn't too terribly difficult. And then the next statement is, how many decimal places to the right did I move it?
4.
I moved it to the right 4. So I have a 4 up here. Next statement is, which way did I move the decimal? I moved it to the right. When you move the decimal to the right, the exponent is 0. When you move the exponent to the left, the exponent is plus. Okay? So if I have 3, 2, 5, 6, 0, 0, 0, 0, and my decimal is at the end like that, I need to move the decimal point between what two numbers?
1 and 6. Probably 6 and 0. Oh, no. 3 and 2.
3 and 2, thank you, Elias. Between 3 and 2, why did you change it to 3 and 2?
There's only one
Just
number.
one of them has to be.
One of them has to. You can't have more than one number on the left or to the left of that decimal. Second step, a 10, or a times and a 10. Now you have to decide, did I go to the left or did I go to the right? Well, I went to the left, so I add 1, 2, 3, 4, 5, 6, 7. So what it means when you have it in scientific notation is our decimal place is 7 place values wrong. In order to get it right, I have to, move them back. So 7 place values to the left of where it actually is. What if I have something like 0.0003 times 10 to the negative 6. That is incorrect, an incorrect way of writing that in scientific notation. We want to correct that. So, like Elias was saying, this would turn into a 3 because that means we'd have our 1 unit, or our 1 digit to the left of the decimal. But what do I do with the exponent that goes up there and that -6? Yes, Adam? Okay, I move the decimal place which way? I moved it to the right. So that means that I add or subtract to that -6. Add a negative number or subtract, which gives me 10 to the -10. These things confuse the daylights out of me. I can do calculus all day long, but give me a scientific notation, it's like, oh, which way do I go? What number goes up there? I always get the right number, it's just whether it's negative or positive. I have to sit back and think about. Okay, so, knowing that bit of information, let's look at 0.0003 times 10 to the -10. No, -6. You just said -10. Last one. And we're going to multiply that times 4,000. And then we're going to divide by 0.006 times 10 to the 15.
To the 15.
Yeah, and then we're going to multiply that times 2,000 times 10 to the 4th. You done these before?
Yeah.
Yeah. Okay, what I want you to do is take each of those 4 parentheses and write those in correct scientific notation. So just go that far right now. Okay, first scientific notation, the 0.0003 times 10 to the -6 is going to turn into what?
3 times 10.
Okay. 4,000 is going to turn into, all right, 0.006, that's going to turn into,
6 times 10 to the 4.
and 2,000,
2 times
10 to the what?
7.
Okay, anybody know what to do with it from there? You don't have a calculator.
You just multiply the 3 and the 4.
Okay. We're going to multiply these numbers, and then we're going to multiply these numbers.
Multiply or add?
We're going to multiply, which means you add the exponents. So 3 times 4 is 12, times 10, -10 plus 3, because when you multiply numbers with exponents, you add the exponents, -7, over 6 times 2 is 12, times 10 to the 19. Okay. And then the next step is divide your numbers. So when you divide those numbers, you get what? 1, 12 over 12. And then we divide our tens with our exponents. And when you divide, what do you do with your exponents? Subtract. So -7 minus 19, and you're done.
Wouldn't it also be like you bring the 19th up to the top, which turns it to negative, so then
Yeah, same thing. Tommy?
So do you just move it down or what?
No, you leave it just like that. That negative sign in scientific notation just tells you what direction the decimal is actually supposed to be.
So what is the 1 for?
Well, the 1 is just because we have 0.0000 all the way down 1. 26 places, yes. All right. Next section of this.
Draw that out rather
Line.
So far, as far as two statements of equality, when we've been doing system of equations where you have two variables and two equations, we've dealt with so far coins, number of nickels and their value, and did system of
Time
equations.
and rate now.
No, not yet.
Yes.
That'll be later. So now what we're going to do is we're going to start looking at ones that aren't coins. So, example 21.2 on page 102 says the ratio of two numbers is 3 to 4. What are those two numbers? Well, one of the ratios is 3 and 4, but it could also be
16.
9 over 12, because that reduces to 3/4. Or 12 over 16 reduces to 3/4. So I mean, there's an infinite number of numbers. So all I know is that I have two values, an x and a y, that when I put that x number up and the y value up, I get a fraction that will reduce to 3/4. So that's all that's saying, that ratio is that whatever number x is, whatever number y is, when we put them in a fraction, reduce to 3/4. Okay? So I know that's true. That x over y reduces to 3/4. It also says their sum is 84. That's all the information they gave me. How many equations do I have up there?
2,
How many variables?
2.
So I can solve it. Okay? So I'm good to go. As long as I get two equations and I've got two variables that are the same in both of the equations, then I'm good to go. So how do I solve that at this point? Kendra, give me a good guess. Educated guess, please.
You change the x plus y equals 84 and make it x equals negative y plus 84, and then substitute that for the x, right?
And then take this
And put it
and substitute it in there.
Yes. Would you do that?
You can do that. I don't know if I would, but it works. What you did was correct. Okay, Madison, what are your thoughts?
Could you cross multiply that, and so then you'd have 3y equals 4x?
What were you going to suggest doing, Erica?
Same thing as Kendra.
Okay. Okay. Either one works. And I don't know, just glancing at it, which one is the easiest or most difficult, Kendra. So, yours might have been easier. I don't know. Okay, so how did that help us, Madison?
Because then you can change your bottom equation to x equals minus y plus 84. And then you could put that in for x.
I can put what in for x?
Because you have to do
That
that. you know.
84 minus y in for x on the top equation.
Ah,
3y equals 4 times.
you're going to do that. Okay. I mean, yeah, basically it's the same thing. It's just they're doing
It's
the
just a
orders
little bit
different.
easier to do it and not a fraction.
Or any other options. The other option is solve this. And then when you see a y here, put 4/3 x in. Yeah. Yeah, that's not a very good option. Still works, but you end up having your head explode before dinner tonight, and then your mom has to clean up the table, and it ends up being a mess. So, anyway, 3 different ways, and one of the key things, guys, is as long as you're algebraically following the rules, it doesn't matter which way you do it. You're going to get the right answer. Some of you will get the wrong answer because you think you're following the rules, but always works. Okay, so then you solve your y, solve for your x, and you're a happy little boy or girl. What if I have the sum of two numbers is 128? How do I write the sum of two numbers as 128?
X plus y equals 1.
X plus y equals 128. If I also say their difference is 44. How would I write that?
X minus y equals
X minus y equals what?
44.
Okay, do you see a problem with that?
What if
Yes.
y minus x?
What if y is bigger than x? It's not going to equal 44, is it? It's going to give you a negative number. So one of the things that I suggest doing is say, when you're dealing with numbers like this, put large plus small equals 128, and then large minus small equals, is that 44 or 144? 44? Then you know the larger one has to go first. If this equaled negative 44, then you knew the small one would have to be first in order to get a negative. So it just, by using L and S for large and small number, it just makes it a little bit easier to keep from getting confused about which one's the biggest and which one's the smallest and how do we get a negative and positive and all that
Could you
uh,
do x minus 44 equals y,
Yeah?
and then put smaller, bigger one in for x?
Actually, what I would end up doing with this one, Madison, is here's my problem. Those are going to cancel.
No, okay.
And then I just divide and done.
Dude. Wow.
Dude.
I didn't even think of that.
So that gives me 86 for my L and go from there. So be looking for the opportunity, sometimes substitution is easier, sometimes elimination is easier. Obviously elimination was easier on that one. Okay.
Yeah.